Chapter 3, Lesson 2 discusses logarithmic functions. Okay, logarithmic functions are the inverses of exponential functions, which is why they are always grouped together. So relating logarithmic and exponential form. Logarithmic form is log base b of x equals y if and only if b to the y power equals x, which represents our exponential form. Okay, b is both the base of the log and the base of the exponent. Okay, b must be greater than 0, but cannot equal 1. Okay. We also know that x cannot be 0, because if you, in exponential form, if y is 0, it's going to equal 1. If y is negative, it creates a fraction. And if y is positive, it creates a whole number. Okay, so x can never be 0 or less than 0. So remember, it never crosses the horizontal asymptote. So we know that x has to be bigger than 0. Now we're going to graph f of x equals 3 to the x power with a dotted line. And then we're going to graph the inverse with a solid line and analyze the graph. So this is a review from 3.1, graphing exponential functions. Remember, f of x is the same thing as y. So we have y equals 3 to the x power. Okay. I'm going to make a table of values. And I'm going to choose values for x, like -2, -1, 0, 1, and 2. I'm going to plug those into the exponential function. So 3 to the negative second power is 1 divided by 3 to the positive second power, which is 1/9. 3 to the negative first power is 1 over 3 to the first power, which is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. And 3 to the second power is 9. Okay. I'm going to graph this function using the points, and I'm going to use a blue pen rather than using a dotted line. I'm going to go left 2 up 1/9, left 1 up 1/3, 0, 1, 1, 3, and 2, 9. And I have the curve. Now, to find the inverse, we switch x and y, and we solve for y. So if I switch x and y, we have x equals 3 to the y power. Notice this is an exponential form. To solve for y, I'm going to put it in logarithmic form. So this would be log base 3 of x is equal to y. Okay, so my inverse function, f to the -1 power of x, is log base 3 of x, and we have solved for y. Now, when we actually graph this, to me, it's easier to use exponential form, which is x equals 3 to the y power. So when I make my table of values, it's going to be easier to choose values for y and get x values in return. So for y, I'm going to choose -2, -1, 0, 1, and 2. When I plug those in, I get positive 1/9 for x. When I plug in -1, I get 1/3. 3 to the 0 power is 1. 3 to the first power is 3. And 3 to the second power is 9. So I'm going to graph this table, the ordered pairs. So I have 1/9, -2. So I'm going to go right 1/9 and down 2. 1/3, -1. So I'm going to go right 1/3, down 1. I have 1, 0, 3, 1, and 9, 2. Logarithmic functions have vertical asymptotes, where exponential functions have horizontal asymptotes. Okay. Notice my exponential function is a function because it passes the vertical line test. It is a horizontal, it has an inverse, so it's a one-to-one function because it passes the horizontal line test. And because these are inverses, when we graph them, they are symmetric about the line y equals x. So if I fold the exponential function across the line y equals x, it will fold onto the logarithmic function. Okay, so we can see that logarithmic functions and exponential functions are inverses of each other. Now we are going to spend some time evaluating logarithmic and exponential functions. Now, before we do that, I want to go down to the bottom of the page where it talks about common logarithms and natural logarithms. Okay, a common log is logarithm with base 10. Now, most of the time, when the base is not 10, there will be a number written to the down and to the right of the log. When no number is there, then the base is 10, and that represents the common log. Okay, the natural logarithm is logarithm with base e. We write the natural log ln, so ln of 1 is really log base e of 1, and the natural log of e to the x power is log base e of e to the x power. Now, I'm going to stop this video here. Okay, this is the main ideas from the lesson. In the next video, we're going to go through some examples, and once we have a better idea of the examples, then we'll come back and look at some of the basic properties of logarithms and common and natural logs.